Welcome to the deep dive, everybody. We're going to be exploring, a really cool research article today from Science Robotics about a prosthetic hand
Oh, cool.
that's pushing the boundaries of what's possible, mind control, but like way more nuanced and elegant than you'd expect.
Right.
We're diving deep into a prosthetic that promises to restore like really natural fluid movement, even the ability to like manipulate objects with the same kind of dexterity that you have with your own hand, which is kind of wild.
Yeah, it's really exciting stuff. Current prosthetics,
Right.
even the high-tech ones, can feel kind of clunky and detached.
Yeah.
They just can't replicate that natural flow and precision of like human movement.
Right, right.
Imagine trying to, I don't know, pick up something delicate or thread a needle
Yeah.
with a hand that just doesn't quite respond the way you're thinking.
Oh, yeah, that would be incredibly frustrating. It's like, what's the point? This new prosthetic, it's called the SoftHand Pro-2, and it takes a completely different approach.
Really fascinating. Yeah.
And it uses a design that's like inspired by the way our brains already control our hands.
The SoftHand Pro-2
Right.
is remarkable. It's kind of remarkable in its simplicity. It has 15 joints,
Wow.
mimicking that complexity of a human hand.
Mm.
But it's all driven by just 2 motors,
Really?
which is a huge departure from
That's wild.
traditional prosthetics,
Okay.
which often require a motor for every single joint.
So 2 motors for 15 joints.
Yeah, I know.
How is that even possible?
That's the magic of it, right? It's this very clever tendon-driven system,
Okay.
much like the tendons that control movement in our own hands.
Oh, interesting.
And this allows for a continuous range of motion, right? You can blend
Yeah.
between different grasps seamlessly, just like you do naturally.
So it's like more analog
It is.
instead of digital. It's like
Right.
this continuous.
Exactly. And it's
Yeah.
based on this concept of postural synergies, which is a big,
Right. Yeah. I remember reading about synergies in another study.
yeah.
Those are like the natural groupings of hand movements, right? That our brains use to kind of simplify these complex actions.
You get that spot on.
Interesting.
Yeah. Think about like how you instinctively would pick up a pen versus a coffee mug.
Oh, right.
Your fingers just kind of naturally adjust to the shape of the object, right?
They do.
You're forming different grasps without even thinking about it.
I never thought about it like that.
And those subtle shifts in finger position, those are synergies in action.
Oh, that's really cool.
Yeah,
So the SoftHand Pro-2 is designed to actually work with those natural synergies,
it is.
which makes it easier to control with fewer motors, which is pretty ingenious.
Yeah.
But the article mentions that they actually went a step further and they were looking not just at muscle synergies, but at the motor neurons that control them.
They did.
Why is that so important?
So that's really getting to like the heart of the matter, right?
Right.
Motor neurons are like the direct link between our brain signals and muscle activation.
So it's like a direct line to the muscle.
Exactly. They're the messengers
Interesting.
that translate our intentions into physical movement.
Right.
And by decoding their activity,
Yeah.
we can tap into a much more precise
Wow.
and detailed level of control
Yeah.
than we ever could before.
That's fascinating. By going straight to the source of the movement,
Right.
it seems like the researchers basically bypassed those limitations of traditional like muscle-based control.
Yeah.
So what did they find when they actually started analyzing these motor neuron signals?
Well, they found something pretty remarkable.
Okay.
Motor neuron synergies are way more complex,
Oh, wow.
and they contain a lot more information than those muscle synergies that researchers have been studying for years.
Really?
It's like they found this.
So that was like the more basic version in the
Absolutely.
language, and now they found like the
Like a hidden language.
yeah, the full.
That our brains use to orchestrate even the most subtle hand movements.
That's wild. So using motor neuron synergies then allows for finer control and less noise in the signal, right?
That's the idea.
That seems almost too good to be true.
It does sound pretty amazing.
Did the researchers actually like test this new control system with real people?
They did.
Okay.
And the results were quite impressive. They tested it with both able-bodied participants and amputees, and
Okay.
they had them do a virtual control task.
So how does a virtual control task work? Like, are they actually controlling the SoftHand Pro-2 with their minds?
Not quite, not yet.
Okay.
It was more like they were controlling a virtual hand.
Right.
So they were using their motor neuron signals to move a cursor around on a screen
Okay.
And then that cursor movement would be mapped to the SoftHand Pro-2's movement.
Oh, so they were using their thoughts
It looked
to
like a
control the prosthetic, but in like a simulated
In
environment.
a virtual world, yeah.
Okay, what kind of results were they seeing?
Pretty amazing, actually.
Yeah.
I mean, the difference between using motor neuron synergies versus traditional muscle synergies
Right.
was like night and day.
Wow.
People using that motor neuron control
Right.
could access a much wider range of movements with that virtual hand.
Interesting. So it's like they had a bigger vocabulary for controlling the prosthetic.
Exactly.
Which makes sense considering how much more information those motor neuron synergies actually contain.
Right.
Did they notice a difference in the precision of their movements as well?
Absolutely.
Okay.
With motor neuron control, their movements were just so much smoother
Okay.
and more controlled. There was
So less jitter.
way less jitter, less overcorrection, which is often a big problem with traditional prosthetics.
Yeah.
It just feels really unnatural.
Right. So that smoother control would make like everyday tasks
Oh, yes.
so much easier.
It would be a game changer.
Yeah. Imagine trying to like write or eat.
With a hand that's constantly overshooting or undershooting its target.
Right. Exactly.
Super frustrating.
Impossible.
Yeah.
What about the participants themselves? Did they have any feedback on the two control methods?
Oh, they definitely did.
Okay.
Once they tried both, they overwhelmingly preferred that motor neuron synergy control.
Interesting.
They said it felt way more intuitive and easier to use,
Okay.
and it required less mental effort, which is huge,
Yeah.
right? If you're going to be using this thing all day long.
Especially for, long-term use.
You don't want to be, like, exhausted.
Right. It's got to be something that becomes second nature.
Exactly.
It sounds like this new control system really does change the game in terms of how natural and intuitive a prosthetic can feel.
Absolutely. It's really exciting.
So I'm kind of curious about the technical side of things.
All right.
You mentioned before that motor neuron synergies have this, higher dimensionality. What does that mean exactly?
Okay, so imagine a piano keyboard, right?
Yeah.
Muscle synergies are like having access to only a few keys.
Okay.
You can play some basic melodies, but you're pretty limited in terms of your expression and complexity.
Right.
Motor neuron synergies, on the other hand, give you access to that whole keyboard.
Oh, wow.
All the keys.
So with motor neuron synergies, you have this wider range of like notes to play.
Exactly.
Which can result in these more nuanced and intricate movements.
Exactly.
That's a great analogy.
Fine.
It really highlights the difference in the level of control that you can achieve.
That's the whole idea.
So this greater dimensionality is why motor neuron signals provide like a much richer language of movement.
Yeah.
It's like the difference between speaking in like basic phrases versus having a full like expressive conversation.
Right.
That's pretty cool.
Yeah.
This is really groundbreaking stuff. We've talked a lot about the benefits of using these motor neuron synergies for prosthetic control.
It's pretty amazing.
But what are some of the challenges that the researchers might face in actually bringing this technology to the real world?
That's a great question.
Yeah.
One of the big ones is the complexity of the algorithms that are needed to actually decode these signals in real time.
Oh, right.
They require a lot of processing power,
Okay.
which can make the system kind of bulky and expensive.
So making the technology more portable and affordable will be like a key focus moving forward.
Absolutely.
What about the sensors that are used to detect those like really faint motor neuron signals? Are there any challenges there?
Definitely. So the HD-SEMG sensors that they use in this study require very careful placement.
Oh, okay.
And they can be really sensitive to like movement artifacts.
Interesting.
So improving the robustness and the user-friendliness of those sensors is going to be essential for making this technology practical for everyday use.
It sounds like there are a lot of moving pieces that need to come together to make this technology widely accessible.
It's a big challenge.
But the potential benefits are so significant that it's definitely worth pursuing.
Absolutely.
And it's not just about prosthetics, right?
Right.
This research could have implications for like other assistive devices as well.
Absolutely. Think about wheelchairs that respond seamlessly to the user's intentions. Or exoskeletons.
Wow.
That can provide strength and mobility.
Yeah.
But feel like a natural part of the body.
The possibilities are pretty incredible.
They really are.
This deep dive has been truly mind-blowing.
I know. It's fascinating stuff.
We've covered so much. From the science behind motor neuron synergies to the potential impact on the future of prosthetics and these assistive devices.
Yeah, it's really exciting.
Before we wrap things up, let's take a moment to digest all of this incredible information, and we'll be right back to discuss the key takeaways from our dive and what this research means for the future of human-machine interaction. We're back for the final part of our deep dive into the future of prosthetics. We've covered a lot of ground, from the limitations of current devices to the potential of these motor neuron synergies.
We have. It's been pretty mind-blowing.
Yeah, what stands out to you the most about this research?
I think the most exciting part is the shift in focus from, simply replacing a limb to truly restoring natural movement and control.
Right.
It's not just about function. It's about restoring this sense of agency and embodiment.
Right.
Imagine being able to effortlessly shake someone's hand, or use chopsticks with the same dexterity you had before.
Right.
That level of control can really profoundly impact a person's life.
That's amazing. It's incredible to think that we might be on the verge of prosthetics that actually feel like a natural extension of the body rather than a separate tool.
Exactly.
But as with any new technology, there are challenges to overcome before this becomes a reality for everyone, right?
Yeah, absolutely. And making this technology more affordable and accessible, I think, is going to be crucial.
Right.
Right now, the systems that are used to decode these complex motor neuron signals are really expensive.
Yeah.
They require a lot of processing power.
Right.
So making them more compact and efficient is a big challenge for researchers.
Right. And we can't forget about the sensors either.
Right.
They need to be way more robust and user-friendly for everyday use.
Absolutely.
It's amazing how much progress has already been made, but there's still a lot of work to be done.
Yeah, for sure.
But the progress so far is incredibly encouraging.
It really is.
We're seeing this convergence of engineering, neuroscience, computer science that's pushing the boundaries of what's possible in human-machine interaction.
Absolutely.
You mentioned earlier that this research actually has implications beyond just prosthetics.
Yeah.
Can you expand on that a little bit?
Yet imagine a world where wheelchairs respond seamlessly to the user's thoughts.
Wow.
Allowing for effortless navigation and control.
Right.
Or exoskeletons that can provide strength and mobility, while feeling like a natural part of the body.
It's like we're entering this new era.
It is.
Where technology can actually augment our abilities and empower us in ways that we never thought possible.
It's really incredible.
This has been a fascinating deep dive into the world of, cutting-edge prosthetics and the future of human-machine interaction.
It has.
What's the one takeaway that you would like our listener to walk away with?
I hope they understand that we're on the cusp of a revolution.
Okay.
In how we interact with technology.
Okay.
By tapping into the brain's own language of movement,
right,
we can create a future where machines aren't just tools.
Right.
They're extensions of ourselves, seamlessly integrating with our bodies and our minds.
It's an exciting future to imagine. Thanks for joining us on this journey of discovery.
Thanks for having me.
Until next time, keep diving deep.